What we're looking at here is our low side vapor pressure temperature gauge. It is blue in color. It's on the left-hand side of our manifold. It has a zero adjustment, so you can adjust the zero on it. It also goes up to 500 psi because the blended refrigerants that we're using now have a higher pressure. And the hose has to be 800 psi, and it is blue also. As we're looking at our vapor pressure gauge, the outer numbers on our dial here, that's the vapor pressure coming back to the unit, and it's measured in 5 psi increments. Down at the bottom, in the middle of our suction vapor gauge, are the refrigerants that work with this particular gauge: R22, R410A, and R404A. These numbers here correlate to the temperature chart that is built into the gauges. These gauges will not work on any other refrigerant besides these three right here. So if you're using another type of refrigerant, 409 for instance, or 134A, you have to use the gauges that correlate with that particular refrigerant so you can get your pressure and your temperature correct. When we're looking at this part of our vapor gauge, down here at the bottom in this little red zone down below zero, so that means it's in a vacuum, it's measured in inches of Hg. Well, on the periodic chart, Hg is mercury. So when we're looking at this scale right here and we're drawing a vacuum to get down to 99.99%, you have to be below 500 microns or 29.9 inches of mercury in vacuum. That's what this scale shows right here. We used to only have this to go by, but now they have vacuum gauges that you put on, and it reads in microns. And the EPA regulation on this is that we have to be able to draw our units in a vacuum down below 500 microns. This vacuum chart that I have here is showing that if you get down to 500 microns, which is in the middle of the chart here, you're going to be now right around 99.99% in a vacuum. There'll also be about 29.9 inches of mercury in vacuum. These points show on our gauge, other than the percentage of vacuum, it shows us that 29.9 on our gauges will be at an adequate vacuum for our systems. These inner dials on our gauge here are saturated refrigerant vapor temperatures for the 4 different refrigerants, and also the colors on here correspond with the color of your refrigerant jug. Green for R22, and I call it pink for R410, and kind of an orangish red for 404A. When we're looking at the saturated vapor temperature on the 3 scales for the 3 different refrigerants in here, all of these scales in here are on 2-degree increments. This is where the pressure temperature part of our gauge is. It's got a built-in pressure temperature chart. And what we look at is we're looking for between a 40 and a 50 degree coil or 40 to 50 degree saturation. There's a lot of things that come into play with that. But here I'm showing 45 degree saturated temperature on our refrigerant, and it's showing about 130 psi. This, if you take a regular PT chart, which I'm going to bring up here in just a second, you'll see that these points correlate just fine. On this refrigerant 410A pressure temperature chart, we find the same points at 45 degree vapor or saturated vapor temperature, and it correlates to 130 psi on our gauge. This part on this gauge here, I'm showing R22, and at a 45 degree saturated vapor temperature, we're going to be reading about a 76 psi. This is the saturation pressure temperature chart for R22. And down here, I have it arrowed at a 45 degree saturated temperature. Your pressure will be 76 psi. This also shows on our vapor gauge. This is a capillary fed evaporator coil. These are orifice restrictors feeding this evaporator coil. These are not used anymore, so these are on really old systems. This is a piston restrictor fed evaporator coil. This is more common now. When you have a cap tube fed evaporator coil, orifice restrictors fed evaporator coil, a piston fed evaporator coil, all of these systems have to be charged by superheat. Superheat. Modern refrigeration and air conditioning's definition of superheat is the temperature of the vapor above boiling temperature of its liquid at that pressure. To calculate system superheat, you subtract the saturated vapor temperature or the gauge temperature for that refrigerant from the vapor line temperature itself. And you should be between 8 and 12 nominally. When we're talking about the system superheat of 8 to 12 degrees nominally, means about an average. But what you're going to need for your field superheat calculations, you're going to need to take the wet bulb, indoor wet bulb temperature, you're going to have the outdoor dry bulb temperature, and you're also going to have to use the superheat chart that comes with the unit in order to know what number that you're shooting for. Using the R410 pressure temperature on our gauge here, we see at 45 degrees saturated vapor temperature with 130 psi vapor pressure, for a 10 degree superheat, the vapor line should be about 55 degrees at the condensing unit.